Welcome. This question says a cylinder of 4 kilograms and 3 meters radius rolls along a surface with a translational velocity of 6 meters per second. And then what is its total kinetic energy? So there's the cylinder, and we can imagine it rolling. There's the center of mass, and the center of mass is moving with a certain velocity, translational. There's a certain mass. But then we have the fact that it's rolling means that we have a certain angular velocity, and we have a certain moment of inertia. And what we say is that our total kinetic is equal to our translational kinetic plus our rotational kinetic. Okay, so our K total is going to equal 1/2 times m times v translational squared plus 1/2 times I times omega squared. Let's put this in a little box so we don't get confused. So K total is going to equal, let's just leave it in terms of letters. Let's do this in blue, so you say, oh yeah, it's to do with the blue bit, so it's 1/2 mv trans squared plus 1/2 I omega squared. And clearly, you know, I know what my mass is, so I know that guy, so I know that guy, and I know what my velocity is, so I know that guy, and I know that guy, but on this side, you know, I don't have a value for I, and you know, I got to work this stuff out. Okay, no big deal. K total is equal to 1/2. Let's leave it in letters. M mv squared, mv translational squared plus 1/2. Now, this is a solid cylinder. Well, I know that the moment of inertia of a solid cylinder is 1/2 m r squared. I learned that before. And so let's make a note of that. We're going to have I solid cylinder equals 1/2 m r squared. And then the other thing I need to do is be able to convert my omega, and my omega is equal to v tangential over r. Remember that from before? So I can say, oh, this is v tangential over r. Okay, so let's simplify. So K total is equal to 1/2 mv tran squared plus, well, 1/2 times 1/2 is 1/4. M is m. Just bear with me. That was omega squared, which is omega squared, which is omega squared. I need to do one more step. I'm sorry. Let me just go back one step. I just I just missed a step out, and I don't want to skip it on you. So we say K total is equal to 1/2 m v tran squared plus 1/2. That would be m 1/2 times 1/2 m r squared times v tang squared over r squared. Remember, you got to multiply top and bottom by, you got to square the top and the bottom. Okay, so if I look to simplify things, it's kind of interesting. That guy goes with that guy. So then I can say, okay, so K total is equal to 1/2 m v translational squared plus 1/2 times 1/2 is 1/4, 1/4 m, and this is v tangential squared. So that then leaves the question of what is the relationship between v translational and v tangential. And v translational is how fast the center of mass is going, and v tangential is how fast a point on the circumference is going. This is v tang, and this is v trans. And it's not obvious, or at least it wasn't obvious to me when I first did these problems, but it turns out that they are the same numerical value. They are different things. V translational is the velocity of the center of mass. V tangential is the velocity of a point on the circumference of the cylinder. They're different things, but for any given motion, they have the same numerical value. If one is 6 meters per second, the other one is 6 meters per second. And so it doesn't matter which one they are. So I can say, oh, this is 1/2 mv squared, 1/2 mv squared plus 1/4 mv squared, which equals 3/4 mv squared. So in this case, K total is equal to 3/4 times 4 kilograms times 6 meters per second squared, which equals 6 sixes is 36, and 3 36s is 108. 108 joules. And there's my final answer, 108 joules. So let's step through this. We visualized, we saw that there were two components to the total kinetic energy. There was the translational kinetic energy, and then there was the rotational kinetic energy, and we put down expressions for both of them. And we recognized that although we had information that we needed to calculate the translational kinetic energy, we needed to do some conversions for the rotational kinetic energy, and the first conversion was to determine what the moment of inertia was, and so we substituted in 1/2 mr squared for the moment of inertia. And then we also recognized that we could express the angular velocity in terms of a tangential velocity in the radius, so we substituted in for that. Then there came a conceptual realization, and that is that the translational velocity is the same numerical value as the tangential velocity. The translational velocity is the same numerical value as the tangential velocity for a given rolling motion. And if the worst comes to the worst, just get yourself some kitchen towel and roll it across the countertop and count how many squares of towel you move by per minute or per second. And then look at it, hold the kitchen towel in your hand and pull the towel away. Rather than rolling the towel over the surface, hold the towel and pull the towel away. And you'll see that, 3 towels per second motion is caused by having 3 towels per second tangential motion. So numerically, they're the same value. And so this question simplifies. Rather than having 2 types of velocity, we have only velocity. We can combine those, and we then numerically get our answer. So there we have it.